Today our focus is on linear equations and rational equations. Please note in this section when Alex is asking you to simplify your answer does need to be in a fraction form, not a decimal form, and you need to have it as a simplified fraction. So if you're typing in a decimal, it's probably going to tell you to retry. Okay, so I kind of have this organized by topics. And so since this is our first lesson, the format, I'll try to explain a little bit. Each topic will have its topic title there. You can match that title up into ALEKS if you are working in ALEKS and you want to find that topic in your notes. The titles should match perfectly. So you can always use your notes to help you if you're stuck. While you're doing your homework. So example 1, solve for y, simplify your answer as much as possible. So we've got this little equation and we are definitely going to need to distribute. To start out, because we have this -7 being multiplied by y minus 1. So we need to distribute the -7 to each of those terms. Our goal here is to solve for y. So we have -7y, and then -7 times by the -1 is +7. And we'll just finish up this equation by, I'm going to add 7y to both sides of my equation. And I'm going to add 15 to both sides of the equation. So we have 22 is equal to 11y. So when we divide by 11, we get the solution y equals 2. Okay, so this is actually 2 topics. On some of the problems, you'll have 1 distribution. On some of the problems, you will have to distribute twice. So we've got to distribute on this side of the equation, and we also have to distribute on this side of the equation. Really, other than that, they are essentially the same. So to keep this video a little bit shorter, I'm going to skip this problem because we're going to be doing a couple that are similar in just a minute. All right, so another topic that you're going to see is solving for a variable in terms of other variables. You'll see some topics that have addition and subtraction, and you'll see another topic that has multiplication and division. So I'm just going to show you one of each of those. Our goal here is to solve for r, so we want to get that r by itself. So we just have a little bit of addition to do. We're going to add s to both sides. And we're also going to add 5 to both sides, which is going to get that r by itself, which is our goal. So on that left side, we now have p plus s plus 5. That's a really good letter S, huh? And that's equal to r. And that would be our final answer. Be careful in ALEKS, just make sure you use the proper case. So it would be a capital P and a lowercase s. Just follow what they have in the problem as far as the capitalizations go. So on this next problem, we're trying to solve for g. So our goal is to get this g by itself. So g is being multiplied by 10, and it's also being multiplied by h. So we're going to do some division here to help get that g by itself. We need to divide by the number 10, which will cancel out that 10 in front of the g. And also, we can't just at the same time really divide by h. And we'll cancel out the h there. So it looks like we now have that g by itself. So g is equal to e divided by 10h. When you're doing division like this, it's a lot better to just do both of the divisions at once. Sometimes I'll see students do things like this. They'll be like, oh, divide by 10, and then they'll have e divided by 10 equals gh, and then they'll say, oh, I need to divide by h, and they'll end up with this really hideous like double fraction over here. Really, it's just a lot better, and it's mathematically sound to just divide both at the same time like I did. Okay, so there's our answer there. And again, if you're typing that into ALEKS, make sure you use a capital E and a lowercase h, or whatever the variables are in the problem you're doing. Okay, our next topic is called solving equations with 0, 1, or infinitely many solutions. So our instructions say for each equation, choose the statement that describes its solutions, and if applicable, give the solution. So like for this first equation right here, we have 3 choices. We either have to mark no solution, we have to type in our solution, or we select that all real numbers are solutions. So let's do this first one, and then we'll kind of talk about what the rules are. Let me kind of get that out of my way for a second. So we've got a couple of distributions that we need to do, and this is why I didn't do that other distribution problem. So we've got 2 distributions to do here. So if we distribute that, we end up with the equation 3u minus 6. So I multiplied both of these by 3. And then I still have this minus 4u. And on the other side of the equation, I have 2u minus 18. So we can combine this and this together on that side of the equation. We have a 3u and a negative 4u. That's a negative 1u. And everything else I'm going to kind of keep the same for a second. And to finish up solving, I'm going to add 18 to both sides of the equation. And I'm going to add 1u. So what I have now is 12 is equal to 3u. And I divide by 3 to get u equals 4. And in this case, I got an answer. And if you do just get an answer, that's the answer. So we're going to mark this middle box, and we would type in 4 as our answer. Well, it won't always work out that way. So I want to show you what it will look like if you have either no solution or infinitely many solutions. So we're going to look at these two. Ooh, sorry, wrong thing. I want the box. I'll show you what that looks like with these other 2 equations. So again, we're going to start with distributing right here and right here. So our equation is going to look like 10 plus 5w, and then I have this minus w that I don't want to forget, and on the other side of the equation I have a 10, and I have a 4w, and if I distribute the 4, I have also a plus 4. Okay, so let's see. There's a lot of things you could do, of course, and always there's some options on what order you're doing steps in when you're working with an equation like this, but I'm going to go ahead and subtract 10 from both sides because I kind of noticed that if I do that, they are both gone. And then over here I have a 5w minus w, so that's going to be 4w equals, and on the right side I have 4w plus 4. I'm going to go ahead and subtract 4w from both sides of my equation, but it's a little bit weird because when that happens on the left side, and sometimes this confuses people, but I have 4w and I subtract 4w, I'm left with 0 on the left-hand side, and then on the right-hand side I have 4. So I end up with the equation 0 equals 4. If you end up with an equation in which there are no variables and it's false, that means there is no solution. False. 0 is not equal to 4. No solution. So we would just mark that one as no solution. And then we can go to our last one. We have a couple distributions again. 5u plus 5. We have also a minus u on that side of the equation. And then on our right side of the equation, we have a 4u minus 4. And then don't forget the plus 9. So if we work this equation and simplify it a bit, we end up with 4u plus 5 equals 4u plus 5. Now it's identical on both sides of the equation. So you could kind of assume at this point that there is all real numbers of our solutions, but sometimes it's safer to just go ahead and see if you can eliminate the variable. So if we subtract 4u from both sides, we end up with the equation 5 equals 5, and that is a true equation. If you have a true equation, that means all real numbers are solutions. So we'll just mark all real numbers and we're good. So that is that topic. Okay, couple more types of equations. We're going to shift our work to what are called rational equations now. Rational equations are equations in which each term, or at least some of the terms, contain a fraction. When a variable appears in the denominator of a fraction, we have to be careful because there are going to be restricted values of the variable because we cannot divide by 0. So we'll have restricted values that we just have to watch out for. So this first equation is a rational equation that simplifies to linear. It's a pretty basic rational equation, and we'll look at some that aren't quite as basic in a second. Our goal is to solve for w, and we need to simplify our answer as much as possible. So I think it's a great idea if you look at the restricted values first. We can't divide by 0, so we know that this thing that's on the bottom cannot equal 0. Well, you can think of it as solving a little bit if you want. That means, or maybe you can just get that in your head, w cannot be 6. So when we finish the problem, we just have to check and make sure that we didn't get 6 as a solution, because that is a restricted value. Okay, so now we can go ahead and solve the equation. If you have fractions in your equation, you want to clear the fractions, is what a lot of people would say. And you do that by multiplying by the denominator. And you have to do that to both sides to keep the equation in balance. Multiply both sides by the denominator. So we're going to multiply both sides by w minus 6. And on the left-hand side, those cancel out. So our equation on the left-hand side just has the number 3, and on the right-hand side, it's 5 times the quantity w minus 6. We can go ahead and distribute that 5 to get 3 is equal to 5w minus 30. And finally, we just do a little bit of simplifying, and we get a fraction answer. We get w equals 33/5. And that is the answer. And that fraction is simplified. Now, just make sure if you get a fraction that does simplify, like if you ended up with 15/45 or something, just make sure you do go ahead and simplify that answer. And I think Alex will prompt you if you haven't simplified it yet, or at least it used to prompt you. Okay, so, but 33/5 doesn't reduce, so that would be our answer. Okay, so now we need to solve a rational equation that simplifies to linear, but this time we have a little bit more complicated situation where we've got some unlike binomial denominators. So that just means our two denominators that you can see in this equation, they are not the same. So our goal here is to still solve for u. And then also just remember we need to watch for restricted values and make sure that we have a true solution. So when you're looking at these ones that have unlike binomial denominators, the first thing you kind of maybe want to think about is just see if you can factor one of the denominators. And this one over here, we can factor just a teeny bit. So if we are kind of just thinking about that 3u minus 15, that's the same as 3 times u minus 5, if you factor out a 3. So I'm just going to rewrite this with that factored denominator. So our equation kind of looks like this now. Now, just like before, we want to do what we call clear the denominator. And this time we are going to multiply by the least common multiple of the denominators. And that just means, we need to multiply by a u minus 5 because, we see some u minus 5s down there, but we also need to multiply by 3. So in this case, we're going to multiply by both of those factors. And we're going to multiply that to each term. So we're going to multiply it here and here and on this last one. So each term gets that multiplier. Now you should see some cancellations. Right here, the u minus 5 cancels. The 3 did not. So that's going to be a 6. In this second term, the 3 cancels and the u minus 5 cancels. So that also just leaves a 6 there. And then in our last one, unfortunately, nothing cancels. I am going to go ahead and multiply that 4 times 3 together. And so I end up with this. So we have 6 equals 6 minus, and I'm going to distribute that, 12 times u plus 60. And there's several ways you could do this. I'm going to just go ahead and add the 12u, even though maybe that seems a little bit weird, and then subtract the 6. So I'm just preferring, I guess, to have a positive coefficient. So that cancels this out. It actually cancels that out as well, and this. So I end up with 12u is equal to 60, and if I divide by 12, I get u equals 5. And so this acts like it's a solution, but I didn't look for my restricted values first. You can, on the last one I looked for those first, this one I didn't yet. You can kind of do whichever you prefer, just make sure you do at some point think about it. So if I look at my original equation, that common denominator was 3 times u minus 5. And we know that we can't divide by 0. So 3 times u minus 5 can't be 0. Well, unfortunately, that means u cannot equal 5. So I've got this contradiction here. I got the answer u equals 5, but I know u can't equal 5 because that causes division by 0. So what that actually means is that there is no solution to this equation. So watch out for those restricted values. That's kind of a tricky sort of equation to solve. So we are going to do one more of those, and then I believe that's it. So I just want to do a quick modification of this problem. It ended up with a negative sign here, but with that negative sign, it ends up almost identical to the last problem where it has no solution. So make that little negative sign go away. Pretend you never saw it. We're going to just pretend that was positive. Okay, so here we go, solving this equation. So we want to think about our denominator, and they don't look the same right now, so we're going to factor this one. And if we factor that, it's 2 times u plus 3. So rewriting this, and maybe you don't need to rewrite the whole thing, but I'm going to rewrite the whole thing. Plus 2 is equal to 4 over, my hand wants to write an x, but it's a u. Okay, so I've just rewritten it with that factored denominator. So we're going to clear the fraction and multiply both sides of the equation by 2 times u plus 3. We want to make sure we've covered all the denominators. So we have a u plus 3 in the denominator, and we also have a 2. So I'm going to multiply the first term. I'm going to multiply the second term. and I'm going to multiply that third term. Now you should see some cancellations. U plus 3 cancels out here, and the 2. Nothing cancels out of that middle term, unfortunately, but the u plus 3 cancels out here. So what I'm left with is negative 8 plus, and this is going to be 4u plus 3, and it's equal to positive 8. I'm going to go ahead and add 8 to both sides. So we get 4u plus 3 is equal to 16. Now, you could 100% absolutely distribute that 4, but I happen to notice that this number is divisible by 4. So if you do notice something like that, you could choose to divide instead of distribute. So I end up with u plus 3 is equal to 4, and then I can just subtract the 3. And we end up with the final answer, u is equal to 1. Now we've got to check our restricted value with a rational equation with variables in the denominator. We have to make sure that that denominator, which was 2 times u plus 3, it cannot equal 0. So that means our restricted value is that u cannot equal negative 3. So it turns out that our answer, u equals 1, is just fine. It's no problem, and that would be our solution to this equation. All right, so that's it for our first section, 1.1.